Great morning, grade 4 students. Today is a lovely day because of you. Let's have another scientific day with Miss Shara. Let's read our work plan for today. We'll have science bits, our sun, discussion of the sun, let's watch, and scientific activity, and we'll end it with thumbs in. For our learning targets, let me read it for you. I can describe the features of the sun. And then I can infer that the sun gives off heat and light to the earth. Now let's have our science bits. Do you know the origin of the word sun? Throughout human history, the sun's powerful energy has long assured its role as the undisputed star of our solar system. So the ancient Greeks personified the sun as a handsome god named Helios. His astronomical pedigree was impeccable. He was the son of the Titan Hyperion and the Titaness Theia. Helios was also the brother of Selene, the goddess of the moon, and Eos, the goddess of the dawn. So, from the Greek mythology, then the word sun means Helios. So let us read our essential questions for today. As you can see in the picture, what is that? Correct. That is the sun. So what are the different features of the sun? How does the sun send heat and light to Earth? Let's keep this in our mind as we go along with our lesson. The big question is, what is the main source of light? Wow, correct. That is the. Did you know that our star The sun is just one of hundreds of billions of stars swirling within an enormous cosmic place called the Milky Way galaxy. The Milky Way is a huge collection of stars, dust, and gas. It's called a spiral galaxy because if you could view it from the top or bottom, it would look like a spinning pinwheel. The sun is located on one of the spiral arms, about 25,000 light years away from the center of the galaxy. The sun is the largest object within our solar system, comprising 99.8% of the system's mass. The sun is located at the center of our solar system. So the big question is, what is the sun? The sun, just what I've said, one star out of 100 billion in our galaxy, which is the Milky Way. It contains 99.8% of the mass of our solar system. It is composed of 70% hydrogen and 28% helium. So this is our star, a star that is very close to Earth. Oh, look at that amazing view. So the sun rises in the morning and giving light to the land below it. It sets in the evening, leaving the world in darkness. It even provides the heat and energy necessary for life to survive on Earth. The sun is a star not so different from the star that can be seen in the night sky. It may look different because the sun is many times nearer to us than other stars, which allow us to see how hot and bright the stars are. So if we are going to ride a car and we will travel from the earth to the sun, it will take 150 billion kilometers to reach the. And if our speed is 100 kilometer per hour, it will take us 170 years to reach the sun. So how does the sun send heat and light to Earth? Yeah, 300 kilometer per second. That's the speed of light. So the light will reach the Earth in 8 minutes. The sun sends heat and light to the Earth in the form of radiation. So all of the energy from the sun that reaches the earth arrives as solar radiation. So what is radiation? Radiation is one way to transfer heat. So when you put your hands near the fire and then you can feel the heat, that is what you call the heat radiation. When you feel the heat of the sun, that is what you call the solar radiation. That's the heat and light from the sun. So another question is, how big is the sun? If you will imagine, okay, there's a big bowl, and then you will put 1,300,000 Earth inside the sun. So million times bigger than the Earth. So 1,300,000 bigger than the Earth. So approximately, if you look at the picture, it's just like a dot near the sun. That is the size of the Earth. The sun is so large that when it is empty, more than a million Earth can fit inside. Imagine that. So big and enormous. Another question. How old is the sun? The sun is 4.5 billion years old as of now, and then it will still be alive for another 5 billion years or so. How hot is the sun? It's 5,800 degrees Celsius. So hot indeed. The sun is a big ball of gas. Particles of gas escape the sun's gravity and begin to flow outward into space. What are these gases? So example is hydrogen, helium, carbon, nitrogen, and oxygen. Now we know facts about the sun. Let's go and have a journey to the center of the sun. So look at the sun. We will talk about the four major parts of the sun. First, we have the corona, chromosphere, photosphere, and the core. So let's start with the core. So just like what we have discussed before, when we talk about the layers of the earth, we have the core. The core is where the fusion is taking place. What do you mean by fusion? Fusion is when two hydrogen atoms fuse to form one helium atom. So fuse means combining. So when they combine, they form one helium atom. The core of the sun is so hot and there is so much pressure. Nuclear fusion takes place. Hydrogen is changed to helium. Nuclear fusion creates heat and photons. Photons means light. The amount of solar heat and light is enough to light up Earth's days and keep our planet warm enough to support life. So what is the temperature? It's 15 million degrees Celsius. The next one is the photosphere. The photosphere is the lowest layer of the solar atmosphere. It is also called the sun's surface. It is essentially the solar surface that we see when we look at the sun in white, means regular or visible light. When we observe sunspots and faculae, means bright little cloud-like features, just like what you can see there, oh, the dot. Yan. That is the photosphere. Can you see the movement? That is the bubbling plasma. And observe it. So the temperature here is 6,000 Kelvin. This one is the chromosphere. This is the sun's atmosphere. The temperature is 10,000 Kelvin. It has a reddish color. So look at that. That's the chromosphere. This is the source of rares or prominences. Wow, look at that. Isn't that amazing? This one is what you call the corona. From the looks of the picture, it's protruding like a crown. So this looks like a crown. That's why it's called corona. You can only see this during solar eclipse. So corona is a luminous envelope of plasma that surrounds the sun and other celestial bodies. It is extended to millions of kilometers into space and is commonly seen yan, during solar eclipse. So the temperatures will range from 1 to 3 million kelvins. Miss, what is solar eclipse? A solar eclipse occurs when the new moon passes between the sun and the earth and totally blocks out the sun. Yan. So that is what you call the total solar eclipse. When the new moon passes between the sun and the earth and totally blocks out the sun. And then the corona happens. So corona is made of ions. This one is what you call the sunspots. So this is the cool spots on the sun. Imagine the sun is very hot, but then again, there is a spot that is cold or cool. Cool spots on the sun. It is caused by twisting of magnetic field. So we call this as the sunspots. I mentioned the word flares and prominences. So we call this as the phenomena on the surface of the sun. Okay, it develops around the sunspot. So the solar flare is the sudden burst that lasts for a minute. And the prominence is the massive loops of gases that gives visual magnetic lines that can last for a month. A solar flare is just a short burst, while prominence will last for a month or year. Okay, so let us look at it closely. You can see the violent eruptions. It can damage satellite even just for a minute, but then again, it can reach Earth. Uh-oh, when solar flares reach the Earth, it can damage our electrical gadgets, right? So even satellites. Now let's look closely at solar prominences or filaments. It follows magnetic force of sunspots. This one is harmless. It will last for a month up to a year. The last amazing pictures of the sun is the solar wind. This solar wind is a stream of energized charged particles, primarily electrons and protons, flowing outward from the sun through the solar system at a speed as high as 900 kilometers per second and at a temperature of 1 million degrees Celsius. So solar wind is made up of plasma. Today, the speed is 449.5 kilometers per second.
The Sun is an extremely complex main sequence type G2V star. Whatever that means. Even the most brilliant minds and NASA don't completely understand that. But learning about the Sun's layers and the basics of what they do is pretty simple. Let's start with the outer layers. Did you know that the Sun has an atmosphere like Earth? Pretty cool, huh? The outermost layer of the Sun is called the corona, which is Latin for crown. Surprisingly, this outer layer is one of the hottest at around 2 million degrees Fahrenheit. That's not cool. At these temperatures, atoms like hydrogen are stripped of their electrons, leaving only a bare nucleus. The Sun's magnetic field lines trap hot plasma and form spike-like shapes, called streamers. These are what give this layer its crown-like appearance and name. The corona also causes the northern lights here on Earth. As plasma flows out of this layer into space, it eventually hits the Earth atmosphere and interacts with atoms and molecules. And these reactions cause the beautiful colors that we see. The next 3,000 miles is the Sun's chromosphere, which is Greek for color sphere. Now the temperature suddenly drops to around 36,000 degrees Fahrenheit. And at these temperatures, hydrogen atoms begin to radiate in a reddish color, hence the layer's name. But against the brighter background layers, you can only see the chromosphere and the corona with special, expensive equipment. However, once in a while, we get a rare look from Earth at both of these layers during a solar eclipse, like the one in 2017. The moon temporarily blocks the much brighter layers, allowing us to see the corona and the chromosphere. Finally, we reach the photosphere, which is Greek for light sphere. This is the layer of the Sun that we're all most familiar with because it's where visible light first appears on the Sun. And now temperatures fall to a nice chilly 6,000 to 11,000 degrees Fahrenheit. The photosphere is also where we see sunspots, which are randomly appearing dark spots that are around 3,600 degrees cooler than the rest of the layer. You've probably seen pictures of the photosphere whether you knew it or not. It's covered in a granular-like pattern, kind of like skin. This pattern is the result of wild convection processes happening in the layers inside the sun. So now you know what the layers of the sun's atmosphere are, and a little bit about how they work. In another video, we'll explore the mysterious internal layers of the sun.
Okay, wow. So those are the facts and features of the sun. Now let's go to our reflection time. Turn your face towards the sun and the shadows fall behind you. Now a lot of things is happening around us. We may feel sad, but let's turn our faces towards the sun. So that means let's look at the light. And the light will it go at our back. So the shadows fall behind you. You cannot see anymore the black part. All you can focus on is the light side. So let's look at the bright side of everything that is happening around us. Let's be positive. Let's stay happy. Let's look at the silver lining, right? Oh, yeah. Ooh. That ends our topic about the sun. Now you can go to Genio and answer scientific activity and the thumbs it. This will be your activity. You will answer the shared blog. Remember the essential questions at the beginning. Now you're going to answer that in your shared blog. So you share your views about the different features of the sun that we talk about, and how do you think does the sun send heat and light to Earth? And then have the wrapped up. You can click heart if you learned a lot, thumbs up if you learned some, and if you want to ask something, just message me and I will gladly answer your questions. So once again, this is Miss Shara saying stay happy. Thank you everyone for another scientific discussion with you. See you next time. Bye.